All right, welcome everyone to this explainer. Today, we are officially putting on our detective hats to investigate a pretty incredible biological mystery. We're going on a microscopic safari to figure out what happens when your body's ultimate defenders, the very cells meant to protect you, actually turn into the culprits. We're taking a fun, sketchy, and easy to understand look right into the histopathology of lymphoma.
Okay, let's dive into this. Normally, your lymphocytes, your B cells, T cells, and natural killer cells, are essentially your internal police force. But sometimes they go rogue. A single cell experiences a mutation and just starts cloning itself uncontrollably. This clonal proliferation, that's the very foundation of what we call lymphoma. Instead of fighting off foreign invaders, these rogue clones amass and create their own totally chaotic environment.
So here is our detective's notepad for today's visual investigation. 1. The lymphoma landscape. 2. The gold standard diagnosis. 3. The Great Divide. 4. Unmasking Hodgkin lymphoma. 5. The non-Hodgkin Wild West. And 6. Burkitt's Starry Night. All right, setting up the crime scene with Section 1, the lymphoma landscape. When we zoom out and look at the big picture, lymphomas make up about 5% of all malignancies, and these are incredibly heterogeneous, meaning it's a wildly diverse group of cancers. They all spring from the clonal proliferation of those lymphocyte subsets we talked about, usually catching them at various stages of maturation. But what exactly pushes these normal cells over the edge to the dark side? Well, the truth is, there's no single smoking gun. It's a complex interaction. Different stressors interact with a person's underlying genetics. We're looking at environmental suspects, like occupational exposure to certain herbicides. We're also looking at infectious organisms. Chronic stimulation from viruses like Epstein-Barr or bacteria like H. pylori can act as massive triggers. Plus, patients on long-term immunosuppressive therapies are at a much higher risk. Why? Because their innate immune system is essentially handcuffed, making it way harder for the body to detect and destroy these rogue cancer cells before they multiply. Which brings us to Section 2, the gold standard diagnosis. Now, while doctors might use a fine needle aspiration or a core biopsy to get a quick sample, the absolute, undeniable gold standard for confirming a lymphoma diagnosis is the excisional biopsy. Why is this so crucial? Because pathologists don't just need to see the individual rogue cells, they need to see the whole neighborhood. Surgically removing the entire lymph node allows them to assess the complete structural architecture of the tissue. Seeing exactly how these cells are interacting with their environment is a massive clue in figuring out which specific gang of rogue cells we're dealing with. Section 3, the Great Divide. And this brilliantly illustrates the massive epidemiological split we see in lymphoma. The vast, overwhelming majority, 90% of all cases, fall under the huge umbrella of non-Hodgkin lymphoma, leaving just a tiny slice of about 10% in the Hodgkin lymphoma category. So what's the actual difference? Well, Hodgkin lymphoma is highly specific. It actually has a unique bimodal age presentation, meaning it peaks first when people are in their early 20s and then again in their mid-60s. And more importantly, it's defined by a very specific, bizarrely shaped cell. Non-Hodgkin lymphoma, on the flip side, is a massive, incredibly diverse category of B-cell, T-cell, and NK cell abnormalities. It's far more common, and the types vary wildly in how aggressively they behave. Let's look for our first major suspect. Section 4, Unmasking Hodgkin lymphoma. In a classic tissue sample, what's totally fascinating about Hodgkin lymphoma is that the actual malignant cells make up a tiny, tiny minority of the tumor itself. The tumor is mostly just a background of seemingly non-malignant inflammatory cells. We're talking normal lymphocytes, eosinophils, neutrophils, and histiocytes. The rogue cells are essentially hiding in plain sight, surrounding themselves with this massive crowd of innocent bystanders. Now, what's really interesting about this slide is what's right in the center of the chaos. Meet the true culprit, the Hodgkin-Reed-Sternberg cell, or HRS cell. Notice its distinct structure. It's an exceptionally large, odd-looking, bilobed cell with two prominent nuclei. It gives it this super bizarre owl eyes appearance. When a pathologist looks through the microscope and sees those owl eyes staring right back at them, they know for sure they found Hodgkin lymphoma. But visually spotting them is really only half the battle. We also have to check their molecular fingerprints using immunohistochemical staining. And oddly enough, even though these HRS cells actually originate from B cells, they often lose their standard B cell markers. They'll test positive for CD30 and CD15, but they are typically negative for CD20. This tricky molecular disguise historically made it a real headache for scientists to determine their true B-cell lineage. Shifting gears now to Section 5, the non-Hodgkin Wild West. Let's speed through a lineup of some of the most prominent culprits in that 90% majority. Diffuse large B-cell lymphoma, or DLBCL, is the absolute heavy hitter, making up 25 to 30% of cases. It is a fast-moving, clinically aggressive disease. Then you have follicular lymphoma at 20%, which is indolent, meaning it's a very slow-moving lurker. You've got lymphomas at 7%, also slow-growing, originating in mucosal tissues and often tied to chronic inflammation or infections like H. pylori. And then there's mantle cell lymphoma, just 6% of cases, but notoriously carrying the worst prognosis, with a median survival of about 5 years. Let's look a little closer at how that slow-moving lurker, follicular lymphoma, actually works. It's basically driven by a genetic typo. Specifically, the BCL2 gene on chromosome 18 swaps places with a gene on chromosome 14. So what does that mean in plain English? Well, BCL2 is an anti-apoptotic protein. So this typo causes the cells to overexpress it. They're essentially giving themselves an unnatural microscopic shield, flat out refusing to undergo programmed cell death when they're supposed to. They just don't die, so they just keep piling up. And when cells refuse to die and continually proliferate, it leads to very real, severe macroscopic consequences. As you can see in gross anatomical views, this clonal expansion creates massive, bulky, physical tumors in the lymph nodes or extranodal organs throughout the body. And that's true whether the lymphoma is incredibly aggressive like DLBCL or indolent like follicular lymphoma.
Finally, the dramatic climax of our microscopic safari, Section 6, Burkitt's Starry Night.
First described back in 1958, Burkitt lymphoma is a fiercely aggressive B-cell lymphoma that actually manifests in 3 distinct ways globally. The endemic form is primarily a pediatric tumor found in Africa, often presenting in the jaw and strongly linked to the Epstein-Barr virus. In the US, we mostly see the spontaneous form, which usually presents as a mass in the abdomen. And lastly, the immunodeficiency-associated form is frequently seen in patients with HIV. In fact, its appearance can actually be an AIDS-defining condition. So the crucial point is how this particular lymphoma looks under the microscope. And honestly, it is breathtaking. Because these malignant B cells are growing and dying so incredibly fast, normal immune cells, called macrophages, rush in to clean up the dead cellular debris. These macrophages, stuffed full of cellular trash, appear as bright, clear holes against a dark, tightly packed background of dark blue malignant B cells. Pathologists literally call this the classic starry sky appearance. The macrophages look exactly like bright stars shining in a dark, microscopic night sky. Now, I mentioned these cells grow incredibly fast. To quantify that, pathologists look at something called the Ki-67 proliferation index, a marker that tells us what percentage of the cells are actively dividing. For Burkitt lymphoma, that number is nearly 100%. It is literally one of the fastest growing human tumors known to medicine. But here's the surprising silver lining. Because it replicates so rapidly, it can also be highly responsive to aggressive chemotherapy. Which brings us to the end of our investigation. By using the gold standard excisional biopsy, we can spot those bizarre owl eyes of Hodgkin lymphoma or the starry sky of Burkitt's. We can pinpoint the exact genetic typos keeping these lurkers alive. So as we continue to decode these unique cellular fingerprints, it begs the ultimate question. How might understanding these exact visual and molecular clues lead us to highly targeted, personalized cures? Treatments that stop these rogue cells dead in their tracks without harming the innocent bystanders. It's a mystery scientists are getting closer to solving every single day. Thanks so much for joining me on this explainer, and keep your curiosity sharp.